Okay. Welcome back again. Look at here, we have in 2.3. Now we are going to manipulate with the graph. What do you mean by manipulating? I mean by shifting to up, shifting to down, right, left, reflecting about x and y axis. Look at here, dears. We have two things, outside and inside the function. Look, outside and inside the function. I have f of x, for example, is equal to x squared. I say maybe the addition outside the function. What do you mean? I mean by we have a shape, outside the shape I have addition. Or maybe inside. What do you mean by inside? You have a g of x, for example, is x plus 2 all squared. Now you can see the difference between them. The first, add out. The second, add in. If you have addition or subtraction outside the function, means that you have shifting to up and down, the same shape up to down. Okay, so later I'm going to talk about the second one, g. So what do you mean by example? For example, y equal to x squared plus 2 as we have. Now I say this is my first, and this is the shifting to up. Understood here? Clear? How about if I say y equal to, for example, x to power 3 minus 5. I know I have x to power 3 is like that, as you told me, as like n. But now minus 5 means that from the origin, shift to down by 5 unit, right? So here's the minus 5, of course, and the graph will be like that. This is minus 5. It's very important to write two things for me, the intersection points and the intersection point here. Intersection of the first one over x-axis, or sorry, on x-axis, and the second intersect is what? On y-axis. You got dear? Then later I'll tell you how to find these points. Not now, later. Good. Now, second part, g of x, if you remember. We say maybe x minus 2, or maybe h of x, x plus 2. So now we add or subtract inside the function. When we have a negation, negative part, we say we are going to shift into right side. When we have negation, addition part, means that we are going to left part. What do you mean by that? Look at here, g of x equal to x minus 2 squared. I know this is my original one. So kindly, during the exam, do the original. Then second, to the shift, I say this is by minus 2, means that we have at 2, we are at 2. Then I have the same shape. As I mentioned, two things very important here. Finding the intersection to give you more accurate graph. Clear, dears? Sorry? Yeah, like a step, how to solve the step. I want a step. For example, if even you did a mistake here, you will get a grade at 1. For example, 4, you'll get at least 1, 2. You know, because you did at least the original shape, then the shifted shape. How about addition? If I have, for example, I say h of x equal to the same things. We have that be 3 squared, means that we have that shape. Then we shift it to left side by minus 3. Then here's my graph. Understood, dears? Good. This is about shifting up, shifting down, up or down. Now, that one wasn't sada, simple. Now it's time to biryani. You know what I mean? Because I know you are hungry. So h of x is equal to what? X minus 2 plus 3. That's what I mean. We have two things together combined. So have we solved that one? Yes. Exactly. So you are free, but it's better to start with the, as you say, to the included in the to the function to here. So I say that's my origin. Am I right? as she said, shift right by 2, then up to what? By 3. That one will be my point, right? My graph. And I know this point is what? 2 and 3. Understood, dears? That one is called later. I'm going to call by vertices. It's called minimum point or maximum point. Understood? Or called extrema point. Clear? Clear, dears? Good. Now, if we another point. We see that horizontal, how we can do it. Now this is the biryani again. We have two things. We have a square root, look. -3, here's -3, +4, here's +4. 4, 3, 4, and 3. I think it's easy, but you need step by step. Kindly, during the exam, do all steps for me. I mean by all steps, I mean by all functions. Now, another thing on the function is what? You have a basic one in 2.2. In 2.3, we are going to reflect them, play with them. How's about reflect? We have two reflection. Look at them. The first one is what? Is outside. The second one is what? Is inside. And he told you, or they told you, that if the outside is what? It's about x-axis, like a mirror. Sometimes you are looking at in the swimming pool. You saw the swimming pool. Sometimes you see you are looking at yourself. It's reflecting, but in the reverse side. So how about that one? Means that if I have a function f of x, for example, x squared, if I multiply by the negative, means that outside. Well, let me give you more example, more accurate example to combine both cases together. Okay, if I have that one, I know this is my graph. Am I right? But now, if I say first f of x is equal to minus root of x, means that I multiplied outside. So, of course, sorry, of course, reflect my x-axis. The green is the original. The red is what? Is the new one. Why? Because you multiplied outside, means that on the y-axis will reflect. Y-axis is positive here, then it's coming to be to negative part. That's why we say x-axis is what? Is a mirror. Is the, or we say reflect about x-axis. Means that x-axis is a mirror. Understood? Now another type of mirror, another type of reflecting is what? If I have a f of x, square root of x, now I say what? Minus x, am I right? So I'll get what? This is my original. Of course, this is my original. Of course, reflecting will be where? Yes, to second quadrant, like a y-axis. At home, you are coming here, you are touching here, is going to be there, right? So it means that y-axis is your mirror. Understood, dears? So when it's inside, y-axis is the mirror. When it's the outside, x-axis is the swimming pool, x-axis is the mirror. Now tell me about biryani. Right? And during the exam, you will see what? No, Sarupia. Come on. Understood, yalla. Day. Yalla, which quadrant? You are right. This is the original. Up to you. You can say, this is my, right? And reflecting that one, you'll get what? Understood here? Reflecting, or maybe the other students say, no, I'm not solving like that. I'm going to solve it like that. This is original. That one b minus, right? Now, reflecting outside will give me the x-axis. Now, multiply by minus here. You'll get what? You will get that part. Up to you. Both cases are true. Whatever you like, you can use. Clear, dears? Now, how about if you make the Sarupia? Like what? What's easy? Like 2 minus square root of x plus 1. How's that? We combine many things here. 3 cases. Yalla. One by one. How we answer? Dears? Which shape do we have first? Which shape? You should answer like that. Okay? There's a square root. Okay. Now, plus 1. Outside or inside? Huh? So left, right, up, down. You are right. Here's left. Understood? This is the graph of. You got it here? Now, what else? Shift to up, right? By what? By 2. Or you can say what? We have what? Reflecting outside, right? So how we reflect? Is outside. X, Y, which one? X-axis, yes, you're right. So I'll get what? I'll get am I right? Understood? Wait. We didn't finish yet. Tamam? Part by part, because if you do together, you'll make a mistake. Now, as she said, or as he said, shift to up by 2. Why? This means that, in my mind, is like that. Minus the square root of x plus 2. So this plus means that to up. So I will have what? I will get what? Minus 1, 1, 2. That's 2 minus x plus 1, y. You can see many examples here in your lecture notes. Kindly check it. It's the x squared. That one is minus x squared. This one is square root of x. That one is minus square root of x. And forget about that one. Later I'll come back to it. And you can see here, this is a Sarupia that we talk about. We have minus 3. Look, this is the original. Minus 3 means that I am here. Minus 2 means that I am reflecting with the x-axis by minus. Then plus 1 means that one unit to up. 1 unit to up. But kindly, during the exam, do not put all in one graph. Put it on 4. Understood? Step by step. Kindly do it like that to get all marks. You got it? It's not hard, but actually need work. Any question about that? Any question 2.3? Okay. Odd and even left. Just let me show you something during the exercise. Try to solve these that we mentioned. We have many cases here, you can see. We have many cases here. And I'm going to share also the exercises of them, like chapter 1, as soon as, inshallah. Then you know how to solve it. Kindly try to solve it daily by lecture, week by week, okay? Good. Now, another things in the 2.3 is what is odd and even. Odd and even function. What do you mean by odd and even function? Yes. We have a function, maybe they are odd, maybe they are even. So how we distinguish between them? When you say we are even function, means that the functions are like that. They are. No, the power is not depends, because tell me about, for example, the third one is even or odd. Not even. Yeah, you are right. So let me do it by the rule, then you can use your trick if you like it. Look at it, Kaka. Generally speaking, when you are talking about function f of x, we say maybe we will give them minus to each x, okay, to each x. Maybe they throw it out the negative, they don't like it, maybe they accept it. Understood? If they throw out, we call them odd. If they kept and they remove the negative part, we say they are even. What do you mean by that? For example, if my function f of x, as we have here, x to power 5 plus x, I say checks the odd or even. How we check it, Kaka? Yeah, we give them minus first of all. I told you to give them minus. So I'm going to write f of minus x, which is equal to, am I right? Tamam? Do you have any comment? No. Now I'm going to check the result. I will get what, of course, because the odd will give me the minus itself, and that's odd. So we got what? If I took a minus as a common, I'll get what? Am I right? Tamam, dears? We took minus to what? To compare that one with the origin. Yalla, I got what? If I compare minus f of x. Am I right? So in that case, I say my function is what? Is odd. Tamam? Okay. How about that function? G of x or f of x, x to power 4 plus x squared. Even. How? How do you know it's even? Let me give the minus. Yes, you are right. Right? And I'll get what? Itself. When I compare that one with the origin function, f of x is what? After getting minus, it's itself. In that case, because you got the same, I say it's even function. Okay, dear? How about the third one, as he say? The third function, look at here. 2x minus x squared. Yalla. First of all, I should give what? Yeah. F of minus x. Then I say 2 squared minus x minus x. Am I right? Good. I know by the first I will get a 2x. By the second, it remains itself. Am I right? That one will be itself. So tell me that one, if I compare, is equal to f of x itself? No, or it's not even at all. So give me the clue. That one is equal to minus f of x itself? No. Why? Because if I multiply minus f of x, I'll get that one. Am I right? So because here's positive, but here's negative, so that's why it's not even equal to f of minus x, not equal to itself. Even is not equal to minus itself. So in that case, we say is neither odd nor even. None of them, right? So it's not like a number. Number is even or odd. There's no third option. No, here we have a third option. Maybe even, maybe odd, maybe none of them. You got it, dears? Good. How are you? Fine? Good. Okay. Five-minute rest and we will finish. No? Shall we continue? Finish what? Why? Time. You are tired. Okay. Okay, I'll give you half of it. It's not hard actually, because nothing. Just I'm going to talk about, then you'll take a rest. Look, Akajan, look. We have just information. We have addition between functions, subtraction, multiplication, division. To understand, Kaka, hello? To understand, look at here. This is your function and g. So if I say f plus g, just combine them. Here's f, here's g. If I say multiply them like that, I say just multiply them here, f and g. When I say put number 4, you can put it 4 minus 2. Clear? It's not a big deal, but the big deal will be next lecture. In that example, kindly remember me. We stop here. Composition between two functions. How we composite between two functions.